Hello, this is Mr. Stansbury. I'm going to take you through the notes on finding side lengths. After this, you should be able to say, I can find side lengths of a right triangle using trig ratios. So, really just have one example to go through with you on this, and that should pretty much take care of us. So, example 2, find to 3 SF, 3 significant figures, the unknown length in the following triangles. So we have these 4 triangles, and remembering that our SOHCAHTOA here. So here's what we want to do. The angle that they give us, they'll always give us, well, in this case here, they're going to give us an angle besides the 90-degree angle. So this is just like what we were doing before. This is our theta. So from this angle, let's see, this side here is the hypotenuse, right? And then from this angle, that over there is the opposite. This here is the adjacent, but we don't know it and we aren't looking for it, so we're just going to leave that out to kind of help help us understand what we're looking for here. So we have the hypotenuse and we're looking for the opposite. So what we want to do now is we look over here and say which one of these trig ratios deals with hypotenuse and opposite, and that would be sine right here. So what we want to do is set this up as sine of the angle, which they give us is 37, equals opposite, which is x, over the hypotenuse, which is 19. Okay. Now, we end up wanting to solve for x, so all we want to do now is multiply both sides by 19, and then we're going to get 19 times sine of 37 is going to be what our x is, so we will just calculate that out. Okay, so we get our calculator. Pretty important at first to make sure that we are in degrees mode, okay? If for some reason you are not in degrees mode, we should be able to hit the mode and degrees, radians, gradients. We want to make sure you're in degrees. So we're already there. So we'll do quit. It'll show us right there that we're in degrees mode. Now we just do 19, and then we can put times, or we don't even have to, and just do sine of 37, and that will tell us that that missing side here, this opposite side, is going to be 11.4. So x is equal to 11.4 meters for this one here. Okay. B, here's the angle that they give us. Across from that is the hypotenuse. We don't have that one. These are the two adjacent sides. That's the hypotenuse, so that makes this the actual, not opposite, but the adjacent. And then across from that angle is the opposite. So we are looking for the adjacent, and we have the opposite. Over here, tangent is the one that deals with opposite and adjacent. So we will want to set this up as tangent of 61 degrees equals opposite, which is 11, over adjacent, which is what we're looking for, which really is the x. Okay? So what we want to do is we want to get x on one side, right? All by itself. So let's do this. Let's multiply both sides by x. Right, and that gives us 11 equals x tangent, having a hard time with that, and there, tangent 61, and then divide by tangent 61, tangent 61. So we get that x is going to equal 11 over tangent of 61, okay? So let's calculate that out. Oops. So we will clear that out, and we're going to simply do 11 divided by tangent of 61, and that gives us 6.1, we'll call it. 6.1 centimeters is what x is going to be. Okay. Now, just one kind of quick note here is if you have, we started with this. We had tangent 61 equaled 11 over x. And if you'll notice at the end, we end up with x equals 11 over tangent 61. So if you'll notice, the 11 stayed in the same spot, and then simply the x and the 61 switch spots. So I've noted over time that whenever I get the variable, whatever I'm looking for is in the denominator, I'm just going to switch it with whatever's over here, okay, with the whole thing. So that's going to just end up being, x equals 11 over tangent 61, which is what we were looking for there. Okay, so that's just a little bit quicker way to do that. If you don't remember that, that's fine. You'll do this enough times and you'll eventually remember that little shorter way to do this. Okay, Before we continue on these last two, let's take a quick little comedy break.
I was in Atlanta at the airport waiting for my bag, and this woman asked to take a picture, and I was like, sure, no problem. And she takes out her iPhone, and she just holds it on me. She just holds it on me right there, and I'm just standing there. She didn't say anything. I'm just standing there. Finally, I just started smiling on my own. Still nothing. Then I started turning into it to let her know I was ready. I was like, there you go. This is it. Snap it. Finally, I was like, did you get it? Did you get it? She goes like this. She goes, nope, I'm getting it. I'm getting it. She's video recording me from a foot away. Like I'm a panda at the zoo. And then she was like, could you do something? Yeah, how about I sweep your legs out from under you? Watch your hip bounce off the mosaic tile. How about that?
All right, these last two here. So here's our angle. There's our hypotenuse so that means that this here has to be the adjacent, and this over here is the opposite. So again, the one that deals with adjacent and opposite is tangent. So let's set this up as tangent of the angle 57 equals opposite, which is 34, over adjacent, which is x. Okay, so now again, I know that my x is in the denominator, so I'm just going to swap these two spots here. Right, so 34 over now tangent 57 is going to equal x. So now I plug that into my calculator and away we go. So 34 divided by tangent 57 gives us 22.07. So let's call that 22.1. Oh, three significant figures, 22.1. Let's see, meters is going to be the distance there. This one here is not actually in three significant figures, so let's go back and let's change that. I need to pay attention to my own directions here. 11 divided by tangent of 61. 6.097. So that would actually be 6.10, right? But there's 1, 2, 3 significant digits. And by putting the 0 in there, that shows that I went to the third digit. All right. Last one. Here's our angle. The angle that they give us across from the right angle is the hypotenuse, and this is the one that's right next to it, which is adjacent. Adjacent and hypotenuse is cosine. So this will be cosine of 12 degrees equals, and again, cosine is adjacent over hypotenuse. So that's going to be 71 over x. Okay, so these two are going to swap spots. X is going to be 71 over cosine of 12, and then it's calculator time. Away we go. 71 divided by cosine of 12 gives us 72.58, so that'd be 72.6 to three significant figures, 72.6 millimeters. All right. Okay, that's really all there is for finding side lengths using our trig ratios. So if you have any further questions on this, please feel free to ask in class. Thanks.